Hello class, this is Professor Howland, and today we're going to talk about inference. An inference is only as good as the observations on which it is based. Great, so what is an inference? An inference is using clues to make an assumption about something else. Let's say you're a state police officer and you're on the highway and you have your radar gun out, and every time a car goes by you record the speed of that car, and you find that the speeds of the car vary between 70 and 80, and using the average you come up with a speed of 75 miles per hour. You can make an inference that all the cars on the highway are driving 75 miles per hour. And you know, as a statistician, that there is a tolerance, and some people will drive faster and some people will drive slower. So today we're going to use M&Ms, and we're going to use different samples of M&Ms to come up with an inference about those colors. If you go to my blackboard and click on my class, MF252, Spring 2015, under Chapter 2, you'll see a lab and a template. Go ahead and click on the Candy Statistics PDF, and that'll open up, and you come down here and you can print out a copy, and you can also save this. And then there's a template that you can open up. You click on that and it automatically starts downloading. There, go ahead and save it, and then open up the Excel spreadsheet. For class, I bought a large bag of M&Ms, and using my kitchen scale, which has an accuracy of plus or minus a half a gram or plus or minus 1/16 of an ounce, I weighed out individual servings of 42 grams or 1.5 ounces. So we'll use 1.5 ounces plus or minus a 16th. And then I had the class dump them out and then separate them into colors. And here is your sample. As you can see, there are 14 green, 6 blue, 10 red, 9 orange, 6 yellow, and 3 brown. Go ahead, pause the video, and write down those numbers. Now, in your template that you opened up, you'll see that I have already entered a whole bunch of numbers. Samples 1 through 9, those are other students, and you could say each student was a sample number or trial number. So go ahead, pause the video here, and fill in the rest of your worksheet. Now once you get that done, you can go ahead and put in a sum up the rows all the way down, all the 10 rows, and also you can do the same thing for all the columns. So here's the auto sum feature. I have Microsoft Excel 2010. The school has 2013. Slightly different, but not very much. So I'm just going to go ahead, click auto sum. It's already going to give me these columns. I'll hit enter, and you can see I have 79 total for the class. I'm going to just scroll all the way across, and for all 10 samples we have a total of 486. Let's talk about mean, median, and mode. The mean is the average. How do we get the average? We do a sum of all the numbers, and then we divide by the number of numbers that we have. Fortunately, Microsoft does have a function in there. You just type in average, and then open parenthesis, select the column, and then close parenthesis, and you can see that we have an average of 7.9, which makes sense if we had 79, so we should have 15.3, etc. I'm just going to drag that all the way across, and there we go. The median, that would be the number right in the middle. If we put these all in order, 4 through 11, which number is in the middle? And once again, Microsoft Excel has a function for that. It's simply median, and once again, and then we can drag that across. So what number is used the most? I'm sorry, what number is right in the middle? Mode is the number that is used the most, and instead of going through and counting how many times the number 8 was used, we'll just do equals mode, put the range of cells in there, hit enter, and percent present, percent promised. These numbers are a given. If you go to sheet 2, you'll see this color, this chart. This was published by M&M Mars a few years ago. They stopped publishing the quantities on their website. I think there was too much variability, and they couldn't guarantee 30% brown and 20% yellow and red. But just for grins and giggles, we're going to put it in there and just compare. So how do we find percent present? Well, if we do equals, and we select our total from that column, and we divide it by the grand total, and we'll close parenthesis there. Better put an open parenthesis at the beginning, go to the end of the formula, and we will multiply that by 100. We should get the present, 16.3% versus 20. Before I drag that over, I want to make sure that the H15 stays selected and doesn't change, and you put dollar signs in front of the H and in front of the 15, so when you drag a formula it stays H15. To easily do that, just highlight H15 and hit F4 if you're using a PC. Escape, and then hit enter right afterwards. There we go, and I'm going to drag that right across, and as you can see, our final cell is 100% the way it should be, and you can see H15 stays the same all the way across. Now, standard deviation. If you remember from class last Wednesday, we talked about the sum of the difference from the sample and the mean squared divided by the number of samples minus 1, and then take the square root of that. Well, instead of typing up a long formula for that, we have in Excel a formula for that. Standard deviation, or STDEV. If you notice down here, you have .P, .S, V, A, P, A. Just stick with the standard deviation, and we will highlight the column, close parenthesis, and enter. 2.1377. That is the spread of this column. And I will move that over. Okay. Now what I'm going to do is I'm going to create our bins. What is a bin? Imagine, if you will, you're going to sort these colors and put them in different bins. You're going to put blue in the blue bin, and green in the green bin, and yellow in the red yellow bin. And instead of labeling them colors, we're going to start off right in the middle here with mean. And that's real simple. I'm just going to click on B16 right here, the mean. And as you can see, 7.90, 7.90. As we work our way up, it's mean plus 1 standard deviation. Well, B16 plus B21, and then we're going to do mean plus 2 times the standard deviation, or B16 plus 2 times the standard deviation, and then mean plus 3 times the standard deviation. And then on the other side we have mean minus 1 standard deviation, the mean minus 2 standard deviations, and the mean minus 3 standard deviations. This column here, just for your reference to see where I got the formulas. And now frequency. We're going to go back and look at our column. We have 5, 7, 4, 11, 9, 8, 8, 8, 9, 10. And we're going to look at our bins. We have, for our first frequency, we're going to look up how many times a number between 14.29 or equal to 14.29 and greater than 12.16. So less than or equal to 14.29 and greater than 12.16. So we go back through our list here. We have 0 that fall into that category, so we'll put a 0 under frequency. For our second one, we're looking for a number that's less than or equal to 12.16 and greater than 10.03. And it looks like we have 1. 10 is less than 10.03, so we won't count that. So we have 1. And then we have less than or equal to 10.03 and greater than 7.9. 8 is greater than 7.9, and 10 is less than 10.03, so 1, 2, 3, 4, 5, 6. So we have 6. Now the next bin, less than or equal to 7.9 and greater than 5.7. So we have 1, in there. One occurrence, less than 5.77 and greater than 3.6. So 1, 2. Less than or equal to 3.63 and greater than 1.50 is 0. And anything less than 1.50 is 0. And I did a sum here of this column to make sure that I have 10, because here we have 10 samples or 10 numbers. So the bin is between these two numbers and the number of times it shows up in your samples. Once you did that, you can create a bar chart. So, highlight your bin, and I'm going to reduce the number of decimals in those, and then I'm going to choose my frequency. Notice I do not choose the total. So what I did was I highlighted one column, held down the control key, highlighted the other. Now I'm going to insert a column, clustered column, and I have two series. Oh boy. Let me redo it. I'm choosing, here we go, mean plus 3, mean plus 2, mean plus s. I'll put that right there, and I'm going to format the data series to fill series. Do a solid fill, and I'm going to change the color to red because it's red M&Ms we're talking about. Delete that, spread that out some more. Perfect. And you can put a title in there if you want. So if we're looking at this, which bin had the most occurrences? The mean plus 6. Plus 6 plus s. Mean plus 1 standard deviation. We had 6 of them. And you can see we had other occurrences, which gives us variability, which makes sense. If we look at mean plus 1 standard deviation, what do we have? We have 10. That means for every bag of M&Ms at 1.5 ounces, we can expect 10 of them to be red. It's an inference. It's not exact, and we know that there's a tolerance. What is the tolerance? Well, the tolerance just happens to be our standard deviation. So if we have 10 M&Ms are red out of a bag of 1.5 ounces with a tolerance of plus or minus 2 M&Ms, so our range is between 8 and 12. Now if we look at our totals, what is our mean? 48.6. What's our median? 48, and our mode is 48. I'm going to go with 48 M&Ms per bag. And we know, looking at this, that there is some variance to the amount in the bags because of weight, not volume. But we can see that the majority are 48. So, if we have 10 out of 48 M&Ms are red, we would have a direct proportion. Ten out of 48 M&Ms are red. I'm going to do something different. That's what I want. No border. I said no border. I'm going to insert an equation. And so I'm going to say, hey, get over here. 10 out of 48. Come back to form. I don't know where my equals X over 1,000. We want to find out of 1,000 M&Ms, how many would be red. Using a direct proportion and then cross multiplying, you get 48x equals 10,000. X equals 10,000 divided by 48. Divided by 48. So we get approximately 208 M&Ms are red out of 1,000. If we have an average of 48 M&Ms in a bag, that is 1.5 ounces. 1.5 ounces divided by 48. We can see that each M&M is approximately 0.03 ounces. We want to know how many M&Ms out of a pound of M&Ms equals are red. If we have 0.03 ounces per M&M, how many do we have in a pound? Well, if we have 10 M&Ms in a bag, multiply it times our answer, that's how many ounces are red. So we could say 0.03125 0.312 per 1.5 ounces is equal to strike that and strike that. How many M&Ms in a pound? There's 16 ounces in a pound, so if we do 16 ounces divided by 0.03125, we'll get 512 M&Ms in a bag, in a pound. Once again, we have 10 out of 48 are red, and this time instead of 1,000 we're going to do 512. So 10 times 512 divided by 48 equals 512, or 5,120 divided by 48. So out of a pound of M&Ms, 107 are red. Make sense? And we'll round off there. Now if you do them all, you'll find out that you'll get more than 1,000 M&Ms when you add up all the colors. Well, you have the tolerances. So we have 208. If we did 12 out of 48, why would we do 12 out of 48? Well, don't forget our standard deviation of 2.13 is our tolerance, so we have 10 plus or minus 2, so we'll do 12 out of 48, so equals 12,000 divided by 48 equals 250. So our tolerance is plus or minus 42. $208 plus or minus 42 M&Ms. And we could do the same thing here. We'll do 12 equals 12 times 512 divided by 48, 128, so we have a difference of 21. So 107 plus or minus 21 M&Ms in a pound are red. Now do that with the rest of the colors, and then make a chart showing the colors. You can, I'm just put it here for now. You can put it where you want, make sure that it looks good. So number of M&Ms per $1,000 pieces per 1 pound. So you can do red, blue, etc. So we have 208 plus or minus 42. You're probably wondering where I got the plus or minus 42 quickly, and you don't see it on your keyboard. If you hold down the Alt button, and while holding it down, you type in 0177 on your number pad, let go of the Alt button, and it shows up. Per pound of candy, 107 Alt 017721. And just fill out the rest of the colors. And then on sheet 2, go ahead and insert a text box and write up a conclusion for me. Submit it on Blackboard, and you have until Friday morning to do it. That's for the day class. For the night class, you have till Thursday evening.